From the last video, we already have some basic knowledge about kinematic terms, as well as the definition of vectors and scalars. However, to further explore their relationships with time, we have to understand the graphical representation of them. In this video, you will learn how to do physics graphs work and how should we know about them in order to do well in analyzing and interpreting data. The first thing we need to know about the graph is a horizontal line and a vertical line, and what the variable linked to the graph represents. In physics, we usually put dependent variables on the vertical axis and independent variables on the horizontal axis, but that's not always the case, so you would have to know the relationship between each variables. Specifically, you can think about how would the increase of x value affect the behavior of the y value. What's more, in physics, we usually talk about the quadrants in our graph. We generally split them into positive and negative quadrants, and not like we're in math. Conventionally, we consider two quadrants, which are quadrant 1 and 4, to simplify systems and problems. One of the most important parts of the graph to know in this class is the slope of the graph. You can understand the slope as rise over run or y over x. It's essentially how much the vertical coordinate change for every changing horizontal coordinate. Some important facts to know are a horizontal line will have a slope of 0, and a straight line will have a constant slope because the rate of change over any length input value intervals will be constant. To compare the slope of the graph, we can describe them as steep or shallow, as shown on the example. If the vertical change over the same interval of input is larger, then we consider the slope to be steeper. In this case, the blue line is steeper than the yellow line. We also need to know whether or not a slope is positive or negative. Basically, if x and y goes in opposite directions, then the slope is negative. If they go in the same direction, then we will say the slope is positive. To explore whether a curve goes steeper or shallower, we observe the rate that a line is increasing or decreasing. If the rate is increasing, then the curve is becoming steeper. On the other hand, if the rate is decreasing, then the curve is becoming shallower. But please be cautious that the increasing and decreasing rate have nothing to do with the concavity like it does in pre-calculus. So we just need to examine it intuitively of the rate that's changing by observing if the curve is becoming a vertical line or a flat line. The y-intercept of the graph is a point where the curve hits the vertical axis. It tells us what would happen to the y variable if x variable is 0. It's important to know the y-intercept to understand what is the initial value of the y variable, perhaps before the experiment or before the independent variables are being manipulated. The last part of the graph we need to learn is the area of the graph. It's beneficial to learn the area under the curve to do a lot of calculations. The area of the graph is defined as the area between the line or curve and the horizontal axis. Therefore, if we have a line in the positive quadrant, then we will have a positive area. If we have a line in negative quadrant, then we will have a negative area. Students often mess up the area by assuming the area is always under the curve, but it's not the case. Remember, if the line is below the horizontal axis, the area will be above the line, sandwiched between the horizontal axis and the line. Lastly, we will end this video by introducing 4 types of graphs and relationship that will always show up in AP Physics 1. For now, you just have to identify them. We will get into all of them later in the course. The first one is a linear graph, or the most ideal model to examine every situation. We can achieve a linear graph by linearizing other graph. Notice that in linear relationship, y variable is directly proportional to x variable. The symbol that looks like a fish represents proportionality. You can understand this as the ratio between the two quantities. The second relationship is quadratic, in which y is proportional to x squared. For now, we can just understand it as y would create a linear relationship with x squared. Students may want to say this graph is exponential, but this answer will be accepted by neither the current College Board AP exams nor your teachers in school. The third relationship is inverse, in which y is inversely proportional to x, or it has a linear relationship with 1 over x. Finally, the last relationship is square root. Based on our previous example, try to figure this relationship out yourself. Leave comments below if you have any questions. In the next video, we will officially start kinematic by combining the graphing knowledge we just learned and the basic kinematic terms. In this channel, we will not only make physics video, but also other AP courses such as APUSH. More material will be added in the future. If you want to learn ahead or simply review the content, please subscribe to our channel. We will appreciate your support. Alright, I'll see you next time.